Hello students, good morning. Welcome to my lecture on chapter number 10 Halogen Derivatives, class 12 Science, Maharashtra State Board New Syllabus 2020. In the previous lecture, we have studied about optical isomerism in halogen derivatives. In that, we have studied about different concepts like stereoisomerism, chiral carbon atom, chirality, plane polarized light, optical activity, enantiomers, and racemic mixtures. Now, today we are going to study chemical properties of haloalkane. First, start with what? Substitution reaction. See, when a group bonded to a carbon in substrate is replaced by another group to give product with no change in the state of hybridization of that carbon. The reaction is called substitution reaction. You know that alkyl halide, I am taking example of methyl bromide or we can say this CX. You know that this bond is what? Polar covalent bond, because alkyl halide is polar covalent molecule. Why is it? See, first of all, halogen is more electronegative than carbon, therefore it acquires partial negative charge, and carbon acquires partial positive charge. See here, Br partial negative, C partial positive. Means here, this carbon is what? Electrophile. And this halogen is what? Nucleophile. Similarly here, this carbon is electrophile, Br is what? Nucleophile. Now, what are electrophiles? Electrophiles, they are what? Electron loving. Electron loving. Electron loving means what? They are deficient of electron. Deficient of electrons. So they gain electrons. Pair of electrons. Electron loving, deficient of electrons, gain pair of electrons. Electrophiles are what? They gain pair of electrons. So they are considered as Lewis acids. Remember that. That is what? You remember this word lead. Lewis acid takes electron pair, and they are what? Positively charged. This much knowledge is necessary to understand substitution reaction. Now come to nucleophile. I am taking one example. I am taking H3O plus, that is hydronium ion. Hydronium ion. Now come to nucleophile. Nucleophile, they are what? Nucleus loving. Nucleus loving means they are rich in electron. Means they rich in electrons, so they donate pair of electrons. They are what? Lewis or Lewis base. They are what? Negatively charged. Remember, if any species having negatively charged, that means they are rich of electrons. Here we can take example of what? Cl minus or Br minus, etc. They are what? Nucleophile. Or you can take OH, hydroxide ion. Okay. Now go to this concept. They are very important to understand substitution reactions. Now, means alkyl have a tendency to undergo nucleophilic substitution reactions. Now, into what? Nucleophilic substitution reactions. They are shown by SN. S for substitution, N for nucleophilic. Now, see the general reaction for nucleophilic substitution reaction. It requires positive charge, it requires negative charge. Here, nucleophile having negative charge. See what happens here. First, the bond between CX breaks, and then you get what? You get positively charged carbocation. What happens? This X takes both the electrons and therefore it forms halide ion. What about this nucleophile? Now, nucleophile having negative charge and carbocation having positive charge, so this attract this carbon atom to form what? This product, and here charge will be balanced. Charge will be what? Balanced. So you get what? Product. This called as what? Substrate. Alkyl halide is what? Substrate. This called as what? Nucleophile. Okay. Now see the order of reactivity. Here, tertiary alkyl halide is more reactive than secondary alkyl halide, which is more reactive than primary alkyl halide. Means the reactive order of reactivity depends upon what? Nature of alkyl group. Now second, it also depends upon size of halogen atom. Size of halogen atom. Here you get what? Ri is more reactive than Rbr, is more reactive than RCl. See here, it is what? More reactive. It is less reactive. It is more reactive. Now come to the meaning of nucleophilic substitution reactions. Nucleophilic substitution reactions, these are substitution reactions in which weaker nucleophile is replaced by stronger nucleophile. Then the reaction is called as nucleophilic substitution reaction. And you know that more basic nucleophile is stronger than halide ions. So here halide ions act as what? Living group or living nucleophile or living group. And this is attacking nucleophile. There are many nucleophiles like amino group, alkoxy group, etc. Now we will study different nucleophilic substitution reactions. First nucleophilic substitution reaction, alkyl halide plus NaOH HBS sodium hydroxide, or you can take potassium hydroxide also. What happens here? Sodium positively charged, OH negatively charged. So this OH acts as what nucleophile? So it easily replace halide ions, that is halogen atom, and you get alcohol plus NaX. It is called as what? Alcohol. It is called as alkyl halide. For this we can take one example. We will take simple example, methyl bromide plus NaOH, or you can take KOH also, HBS, heat. Here you get CH3, it is nucleophile, OH plus NaBr. It is called as methyl bromide. It is called as methyl alcohol. Now see here, hydroxide ion acts as what? Nucleophile. It is a more basic nucleophile, so it will easily replace halide or halogen atom or halide group. Now come to the second. Alkyl halide plus sodium alkoxide. Sodium alkoxide. I have put here R dash. It may R. They are alkyl group. They may be same or different. Here, this group act as what? Act as nucleophile. So here you get what? R O R dash plus NaX. It is alcoholic. It is called as what? Ether. See the examples. Plus NaOCH3. I have taken same alkyl group. It is called as what? Sodium methoxide. Then you get CH3OCH3 plus NaBr. It is called as dimethyl ether. If you take here C2H5, then you get what? Instead of CH3 you get C2H5. Name is what? Ethyl methyl ether. Now look it carefully. I want to rub this. COOH. Alkyl halide, it is called as silver carboxylate. Silver carboxylate. Now you remember here in the product first you put this group. Here it is what? Silver having positive charge and this having what? Negative charge. So it acts as what? Nucleophile. RCO acts as what? Nucleophile. So here you get what? R dash COOR plus AgX is in PT form. It is called as what? Ester. Now see the example. Take CH3CH2Br. It is ethyl bromide. This ethyl bromide react with CH3COOAg. It is called as silver acetate. Heat. What will we get? Put this part first. That is CH3CO then CH2CH3 plus AgBr is in precipitate form. Its name is what? C. This is ethyl group, ethyl acetate. Remember this, ethyl acetate. Now next, alkyl halide plus NH2. That is what? Ammonia. It is in axis. Take alcoholic ammonia. Here, alcoholic. Heat. Here, it is having positive charge. It is having negative charge. So NH2 group acts as what? Nucleophile. So NH2 group easily replace X. So you get RNH2 plus HX. It is called as what? Primary amine, or you can say it is alkyl amine. Now see the example. CH3 CH2Cl, that is ethyl chloride, reacts with what? Ammonia. In axis, it is what? Alcoholic. Heat is necessary. This reaction is carried out under pressure. Heat under what? Pressure is necessary. Pressure. Then you get CH3 CH2 NH2 plus HCl. It is called as ethyl amine. See here, pressure is necessary. NH2 replace halide group. So you get what? Primary amine. Okay. Let's proceed for next. Alkyl halide plus KCN. K having positive charge and cyanide having negative charge. Heat. It is called as what? Potassium cyanide. Potassium cyanide. See, remember, cyanide is what? Ambident ion, and ambident CN is what? Cn. Ambident nucleophile because it has more than one nucleophilic site. So here you get RCN plus KX. It is called as what? Alkyl cyanide. In here it is in alcoholic form. See the example. CH3 CH2 Br plus KCN alcoholic heat. Here you get CH3 CH2 Cn plus KBr. It is called as ethyl cyanide. Now come to next. Alkyl halide plus AgCN, that is silver cyanide. Heat, it is also alcoholic. Here you get RNC plus AgX. It is called as alkyl isocyanide. Now see the example. CH3 CH2 Br plus AgCN. Heat, it is alcoholic. Here you get CH3 CH2NC plus AgBr. It is called as ethyl isocyanide. Now question arises that when potassium cyanide reacts with alkyl halide, you get alkyl cyanide, but when silver cyanide reacts with alkyl halide, you get alkyl isocyanide. See, first of all, Cn is what? Ambident nucleophile. First we consider potassium cyanide. It can be shown by this way. If we take, you know that 1, 2, 3, 4 carbon having 4 valence electrons, carbon atom having 4 valence electrons, 1, 2, 3, 4. But here carbon has one extra electron, therefore it acquires negative charge. Now come to nitrogen. Here now the valency of nitrogen is what? 5. So it contains 5 valence electrons. 1, 2, 3, 4, 5. Okay. Now cyanide ion is what? Ambident nucleophile, because it can attach to carbon as well as it can attach to nitrogen. I hope you understood why there is a negative charge on carbon atom. Now come to potassium cyanide. See, when the bond between potassium and cyanide takes place, then both electrons goes to carbon atom. Both the electrons goes toward carbon atom, and you know that it is what? Ionic compound. Ionic compound. So what happens? K plus C, you get this. So it can easily form. You can easily form bond with what? Alkyl group. These 2 electrons. 1, this 2. So you get what? See, these 2 electrons. This one of the electron here, and this another electron is here. So this is a bond formed between alkyl group and cyanide ions. Now come to AgCN. First of all, AgCN is what? Covalent compound. Because silver is transition element, and therefore when bond between these breaks, what happens? One electron goes to carbon and one electron goes to silver, and therefore carbon having this type of condition, carbon having only one electron, and here nitrogen having two electrons. So carbon is not able to form bond with alkyl group, not possible. So alkyl group can form bond with what? Nitrogen. So you get what? R and C. This is the difference between these two reactions. I hope you understood this part. Same. Alkyl halide plus K that is potassium nitrate, Nitrite. Here heating is not required. Here potassium having positive charge and this ONO having negative charge, so it acts as what? Nucleophilic. What happens here? R O N O plus K X. It is called as alkyl nitrite. If you take one example, CH3 CH2 Cl plus KONO potassium nitrite, you get what? CH3 CH2O and double bond O plus KCl. It is called as ethyl nitrite. Now come to last reaction, alkyl halide plus silver nitrite Here what will you get? Here you get what? AgNO2 NO2. This carries negative charge, it carries positive charge, plus AgX. It is called as, here we get what? R NO. That is what? Nitroalkane. The example, CH3 CH2 Br plus AgONO. So you get CH3 CH2 NO plus Ag Br. It is what? Nitroethane.